Welcome to the 36th session of LMS. Program is for BSc subject mathematics for the 5th semester students. The title of the paper is Numerical Analysis. So in that session we are going to see the third unit, finite difference. Now in this session we are going to study about the relation between the forward difference del, shift operator E and backward difference del. We have a recap what we have read in the last sessions. We have solved the problems which are related to the forward difference, backward difference and the shift operator. Now in this session, at this end of this session, we are able to understand the relations between the forward difference, backward difference and the shift operator E. Now we have a first relation, that is we have to show that del is equals to E minus 1 or E is equals to 1 plus delta. Right? So now I will take the first forward difference, that is I will consider delta of f of x is equals to, what I can say, this is the definition of the forward difference, f of x plus h minus f of x. Right? So now if you see this f of x plus h, this looks like the definition of shift operator. You can see it here, E of f of x minus f of x as it is. So if you take off f of x both sides outside, it will be e minus 1 into f of x. So in both sides delta of f of x is equals to e minus 1 times of f of x. Take f of x both sides, then it left out will be del is equals to e minus 1, or you can say e is equals to 1 plus delta. Right? Second one. So here forward difference del is equals to shift operator E into backward difference del. Now I will consider the RHS part. E times of backward difference del of f of x is equals to, here it is there. Now I apply the backward difference operator formula, definition. That is E as it is. What is this backward difference f of x? It is nothing but, and we know that f of x minus f of x minus h. Right? We have wrote it. Now I will multiply that e to both the functions. So e times of f of x minus e times of f of x minus h. Now I will apply the definition of the shift operator E. What is this e of f of x? E of f of x is nothing but an f of x plus h. Similarly here also e of f of x minus h will become f of x minus h plus h. Right? So now I will write this function as it is. If you simplify, h get cancels. Here remains only f of x. Right? So now this is this part. What is this? F of x plus h minus f of, this is nothing but an forward difference of f of x. Right? We have wrote it here. You can see. So you can remove both sides f of x. Here we have proved that backward difference into E is equals to forward difference del. Right? Now third part, we have to show that shift operator E is equals to 1 minus backward difference del to the power of minus 1. Okay. Now I will consider first the definition of the backward difference. Here it is. Right? So in this part I will shift this f of x minus h to LHS and del backward difference f of x to RHS. So here we have shifted and we have wrote that part. Okay. What is this? This looks like the shift operator e power minus 1 times of f of x. Right? E power minus 1 into f of x. Now you can take in this two part f of x as a common. This e to the power of minus 1 f of x. How I wrote? Here is it. Here we are wrote. See it here. E power minus 1 of f of x plus h is nothing but an f of x. Similarly, I can write that e power minus 1 of f of x is equals to f of x minus h. Okay. So now if you see this part, in this part I am taking off both sides f of x. So left out thing is here it is there. So now I will shift this delta to the LHS. So I will get this part. So it is nothing but an shift operator E is equals to 1 minus delta to the power of minus 1. Right? So next part, backward difference del is equals to e power minus 1 into forward difference del. Right? Now I'll consider this RHS part. E power minus 1 into delta of f of x is equals to e power minus 1. I will apply this forward difference for f of x. What is the definition? It is f of x plus h minus f of x. Right? So now I will multiply that shift operator to both the functions. I have multiplied it. Now by the definition of the shift operator, this will become, right, f of x, because f of x plus h minus h, so plus h minus l will get cancelled, so only remains f of x. Here also f of x minus h, here it is, right? So now how it will looks, this is nothing but an backward difference of f of x. We are wrote it here, right? Now in both sides we can remove this f of x. Remaining thing is e to the power of minus 1 into forward difference is equals to backward difference. Just we have proved it. Okay. Next part. So capital E is equals to e to the power of hd, exponential to the power of hd we have to prove, where capital D is d by dx. Okay. Now we will consider e of f of x. What is this shift operator? By definition I know that f of x plus h, I have wrote it. Now what I will do, I will expand this f of x plus h by Taylor's theorem. We have expanded it. Okay, by Taylor's theorem we have expanded. Right. Now in this part, we can see I wrote f of x as it is, h as it is. This f dash means we know that d by dx. So I wrote capital D here. Right? Instead of this f dash, I wrote capital D of f of x. Okay. Here d square of f of x. Right? Now in this part, you can see f of x plus h into d of f of x plus h square times of 2 factorial d square of f of x. In this part, we are taking off in whole part. In this whole part, I am taking f of x outside. If you take, then left out will be 1 plus h into d plus h square d square. You can see it here, it is there. Right? What are left, we have wrote it here. Right? Now, you can see it here. I wrote this part as it is. Here, this part, it is nothing but an e power x. We have wrote is 1 plus x square divided by 2 factorial plus dot dot dot. So, as per that one, it is nothing but an e power h times of d into f of x. You can take f of x both sides. So left out will be capital E is equals to e power h into d. Hence our proof. Okay. Next, sixth one. So you can see forward difference del is equals to 1 minus e power h minus h times of d. Now I'll consider first e is equals to h to the power, e to the power of hd. The shift operator e is equals to, I am considering this part. You can see it here. Just we have proved in the last problem, fifth problem, that is. Okay, here it is. We are considering this. What is this E? I can say E is nothing but an 1 plus delta. In the last, in one of the problem, in this session we have done that E is equals to 1 plus delta. I am considering that. E is equals to 1 plus delta. So I am substituting that here. You can see it here. E is nothing but an 1 plus delta. E is equals to 1 plus delta. I wrote this, right? This part, right? So e power hd will be as it is. Now 1 plus delta into e to the power of hd. What I will do it? I will shift this one. Reciprocals I am writing. Sorry, I am shifting the numerator to denominator. So 1 divided by 1 plus delta and e to the power of minus h into d. That is nothing but an, I can say that it is, here there should be a bracket, right? So now it will be, okay. So e power minus 1 minus h into d is equals to 1 plus delta to the power of minus 1. So now what I will do, I will expand this RHS by binomial theorem. And after expanding, if you neglect the higher degree terms, okay, then what I am going to get, then it will be only 1 plus delta will be left out here, right? So now I can say that I can shift this minus 1 to LHS, so, or this one to this side, so my answer is here. Delta is equals to 1 minus e to the power of minus h into d, right? So now another one problem, we have to show that 1 plus forward difference del into 1 minus backward difference del is equals to 1. Now I will consider this part, that is 1 minus backward difference del into f of x is equals to, so I will multiply this f of x to both the things. Here I will remove the bracket, f of x minus backward difference f of x. Now I apply the forward backward difference f of x operator definition. So it is f of x minus h. Now if you simplify, only left out will be this part. So I wrote that. So this is nothing but an shift operator. By the shift operator definition, I can write this one as e to the power of minus 1 into f of x. If you remove both sides f of x, here left out will be this one. I will say this is equation number 1. Right? Now I will consider 1 plus delta is equals to e. We know this. This part we know. 1 plus delta is equals to e. We have solved one of the problem in this session. Right? Now multiply 1 and 2. This is 1 plus delta. Here is 1 minus delta, right? I have multiplied it. Here is e, this side is e minus 1. So, sorry, e to the power of minus 1 it is, right? So, I wrote that one, I multiply that. So, if you make simplification this part, so it will be 1. Okay, hence my proof I can say. Now, 8th one, I have to show that e into delta is equals to delta into e. Now, I will consider this part, or LHS part. So now first I will apply the forward difference operator. Forward difference operator definition, it is f of x plus h minus f of x. Now I will multiply this e to both the functions. Here it is. So now now I apply the definition of the shift operator e for this. It is f of x plus h it will become. This is f of x plus h. Now it will become, if you simplify this, this will be f of x plus 2h. I will write this as it is. So if you see this one, this is nothing but an forward difference operator with f of x plus h as a function. Right? So now, only f of x plus h, what it will be? It is nothing but a shift operator e into f of x. You can remove f of x both sides. Hence, we will have our proof. Right? So, 9th part. So, most important we can say. So, here it is. You can see here. Forward difference minus backward difference is equals to forward difference into backward difference. Okay. Now, I will consider this part, RHS part with function. Now, first I will apply the backward difference definition. Here it is f of x minus h. Right. Now, I will apply this forward difference operator to both the functions. Here I applied it. Now, I will write the definition of the forward difference for this one. What is this? F of x. Delta of f of x is nothing but an f of x plus h minus f of x. Similarly, I will apply for this part out of forward difference. It is f of x minus h. Now, if you simplify this, the left out will be, I can say, this will looks like. Okay. This is forward difference. I have wrote it as it is. If you see this part, how it will looks? This is nothing but an backward difference of f of x. Right? So I have wrote it. Now you can see it. So in both the things I can take out f of x as outside. So left out will be my answer. You can see it here. Right? So now some of the books for references. Here they are the books for references by G.K. Ranganathan, Dr. Swami, Prabhakar, Jairam. So these are the books for references. So thank you friends.